And for over 2 decades, ECG has been delivering technical expertise and staffing solutions to leading operators in the ICT industry, that from contributing to the development of Verizon's One Talk service to engineering products for Inmarsat. ECG's impact spans across major global operators. Today we speak with Mark Lindsey. He's a principal at ECG, that to discuss their role in the industry's transformation and the future of telecom engineering. And Mark, welcome.
Thanks, Abe.
Well, thanks for being here. Big show here in Barcelona. How's it been for you so far?
It's been really good. Lots of good meetings, lots of good contacts.
Great. So I have a number of questions to ask you. I want to start with how can lessons from voice over IP inform really the multi-vendor interoperability challenges that exist in Open RAN?
Yeah, I think the voice over IP and the IMS development from about 25 years ago really serves an interesting lesson for Open RAN developers now. We started with really single source or single vendor Open RAN type of deployments that we're seeing now, and then we saw the same kind of thing in the VoIP and IMS world early on, where we saw the big players like Nortel and Lucent really rolling out some of that initial deployment using all their own equipment. But I think that's natural. Some folks have been really a little startled by that. They said, well, Open RAN is not really achieving the success that we were hoping it would achieve. And I think that's a little premature to say that. It's always natural when you're bringing out a new standard to see that the vendors are going to implement it on their own, in their own way. So I think that's one big area. Not to be too startled. It's pretty normal, but it's part of the evolution process. And what we need to see is that the network operators are going to need to push back on those sources, whether it's Nokia and Ericsson or Parallel Wireless, to actually do that testing with other vendors. And so you'll see that really, and we see that a lot at the show, where vendors are starting to work with each other, but it really has to be driven by that customer. I think another big area that's of overlap is the way standards can have options. And so where in Open RAN, there's a lot of good work being done. Standards are getting fully baked right now, but there are always options for whether to do it this way or that way, and that can lead to some complexities. You've got to decide what they are. So one of those options, for example, in the VoIP and IMS world, was just how do we transfer touch tone or DTMF digits through? And there were a half a dozen potential ways that were discussed, and it was because the major vendors had kind of early chosen one or the other. So it's important for the network operators to, as soon as they can, hone in on a de facto standard. Even though the standard's going to allow them multiple options, it's pretty important for them to be able to choose one that's going to be used more broadly. And then cybersecurity is kind of another big area where we see that the networks that were built, they had a kind of natural isolation in voice and telecom networks early on, and then as the newer technology, whether it's based on cloud computing or just IP networking, that is introducing new cybersecurity challenges that the industry is fairly new to. So there's a good game about being talked about zero trust networking right now, which is great. So it's exactly the right idea, but I don't quite think it's actually being realized yet. And that's what I'm telling my clients is you've got to really understand what zero trust networking is. It doesn't just mean some IP access control list. It really means in practice exposing your applications to malware and attackers. And so that's changing things. So there's some lessons where maturity is going to be required, and I think we're seeing a lot of the same kind of patterns that we've seen in other multi-vendor telecom concepts through VoIP and IMS. Really, we're seeing those come back out in Open RAN and development.
Interesting. Mark, I want to move on to some of the key benefits of implementing end-to-end visibility and packet capture capabilities, that in Open RAN really troubleshooting.
Yeah, it's important to have the ability to see what's happening in these protocols. I think this is commonly not appreciated until you get into the deep multi-vendor interop and you've got deadlines, and your network operators are going to wonder, why can't we see what's happening inside my software? There's a trade-off challenge between how much detail do these software-based systems give and then how much CPU power is required to do. But a mistake I saw being made by some of the big vendors, for example, some of the equipment that's sold in the session border controller space, the security space, was that they kind of assumed that CPU was going to be about as expensive in 10 years as it was initially. Well, of course, it's not. It's going to be far less expensive in a few years from now. CPU is always getting less expensive. Well, CPU is required in order to provide debugging and diagnostic data. So when the vendors are just working on just being efficient enough to support massive MIMO through software, for example, that takes a lot of care and a lot of efficiency in the code, but it tends to drive the developers to do less diagnostic, provide less diagnostic data, and that's something the network operators need to push back against and say, hey, we need an option to see what's happening in your decision making internally. So there's a trend to in this industry, but it also happened in VoIP and IMS, to see that the messaging, the official messaging, whether it's diameter or eCPRI, the messaging log is kind of all that's necessary. But in reality, you're going to need packet capture and you're going to need logging capability. It is helpful that in this industry, like in VoIP and IMS, there's a de facto human language, English, because even the vendors need to be able to provide diagnostic data in a language that everyone's going to be able to understand. And then there's also the ability for visibility through packet capture, which is going to be necessary in every case. But it's not something that's it's not something that comes natural if you're just migrating over to a hardware-based system from
Mark,
a hardware-based system.
Let's talk more about log sharing. How can vendors improve log sharing and really diagnostic data that to ensure faster root cause analysis in a multi-vendor RAN environment?
Well, I think that being able to generate logs about the decisions that are being made internally, about how the DU and the CU are interacting, how the DU is interacting with the RU as it boots up, and those other elements, they need to make diagnostic data available to the network operator to be able to help them understand why it's deciding to do what it's doing, and the rationale for the decision making. Not simply that it received a message or that it's transmitting a message, but what was some of the logic for making that decision. And that doesn't come natural, especially from the hardware sort of mindset, the hardware culture. You don't necessarily explain the machinations when you're making a decision, through electronics. You can't. It's not really part of it. But in the software culture, software developers can do that. They will do that, and those things have become really intrinsic to the whole integration and interop process. So now it's become a standard expectation in, for example, the VoIP and IMS world, whereas initially back in 2003 it was not. And I think we're seeing kind of the same sort of pattern repeated with Open RAN, where it's not necessarily the expectation that you're going to get all the internal rationale, but it really needs to become more of the normal. So being able to generate logs so that if I give you some new software and you deploy it in your network, that I can reasonably ask you for some logs to tell me, well, show me the logs when we connected that new radio, and so I can troubleshoot in that way. And that needs to become more of a normal.
Yeah. So what are the biggest challenges, Mark, when operators face when really managing these x86-based server infrastructures that from multiple vendors?
Yeah, it's really interesting. There's a lot of excitement about being able to use standard Intel or AMD or maybe ARM architectures for that, and that's great. I think there's a lot of efficiency that comes through those things. But what you're going to see, if you're doing, let's say you're a big Canadian vendor and you're rolling out a big Open RAN deployment, you're probably going to have a lot of uniformity, and that's great. Every engineer, uniformity, simple code that's going to be able to manage the configuration. They're going to be able to replace servers as cell sites. Those kind of things are great, except for at some point they're going to stop making the server that you were using, and they're going to start making a new one. The new one's going to have a new feature, and you love this new feature, but it's not available on 80% of your network. So you're going to have to make that decision about how do I add support for that new functionality that really will save us a ton of time. It'll help us doing replacements. It'll help us doing maintenance so much quicker. And so you start to have variety there. On the early end, you're not necessarily expecting that. So I think what is the sooner the network operators can start to plan around heterogeneity, where they have multiple server vendors. There's some interest in server vendor diversity today, but it's not really entrenched yet. I don't say it. Usually there's a lot of standardization on whether you're getting your servers from Dell or Lenovo or from HP Enterprise. Those are all great options.
Yeah.
But they're different. There's going to be little differences in how your cell site turn-up process, how the operations work, how the boot up process works, and so understanding that you are going to have differences even between network cards. the way the network cards boot up and attach to the network is going to be different, and that changes things when you're trying to run 10,000 remote sites and never do a truck roll to go visit them. That's really going to change things. So the sooner they start testing that variety and building it into their provisioning and their automation logic to be able to activate sites, and then knowing that they're going to have some variety in those servers, the sooner they do that, the better. The sooner a network operator is prepared for server diversity, the better.
So Mark, why is maintaining independent lab environments really critical for Open RAN operators, and how can they overcome these resource constraints?
Yeah, it's really interesting. When you can depend on your single source vendor to do a lot of your integration testing for you. So you're able to get it all from one source. So for example, rewind 20 years, you could get it all from Lucent. You could go and they would have pre-tested everything for you, and that was great. They did a lot of great work for you. You could get a lot, and there's vendors who will do that now. They're pre-test, everything's pre-integrated. That's great, and that reduces the network operators' need to do a lot of testing themselves. They largely just depend on what the vendor says. If something doesn't work, it's basically up to the vendor to figure out why, because it was something they had effectively certified. But with a multi-vendor environment, we have to remember, it's a completely different story now. There's a demarc point. There's a certain software stack, or there's certain network interfaces that they're implementing to, and each vendor is really only responsible up to that edge. And so it means that you've got to be ready to actually test and be responsible for the edge. So the little place where the two interfaces touch, that's actually your responsibility as the network operator. You can't depend on Rakuten or Parallel Wireless or Samsung to talk about the edges. They're only responsible for their particular interfaces, and maybe where their components touch each other, but generally speaking, the network operator has to take responsibility for that. And so being able to test those things in the lab is really important. Being able to say, oh, we've got a new software update, which is going to happen far more frequently than someone from the hardware culture is going to expect sometimes. We've got a new software update. It's really essential. We have to test this thing, and we have to test it. We have to get this deployed in the next 7 days, because it's a big cybersecurity vulnerability, and the federal government of the U.S. has announced that everyone needs to run the software update in their cell sites. We've got to do this pretty quick. Well, we need to know that it's not going to create regression. It's not going to break things in our network. And so we're going to have a lab to do that, because the vendors are not in a position to be able to test your particular decisions. So every network operator, when you have multi-vendor software-based systems, every network operator is unique. They're kind of a unicorn. They're special and distinct, and they have to take responsibility for that testing themselves. But it does take a substantial amount of effort. That's one of the things the ECG does, is some of that lab testing to actually help with these multi-vendor interop things, where we put it in the lab and then we're able to run testing on the schedule. I've heard stories from the cloud space, for example, where the cloud operator will have thousands of servers, and they'll get an update from Broadcom, for example. It's required, it's a good update, and now they've got to go update thousands of servers. They were expecting to do updates, we'll do updates every quarter, but it turns out now they're doing updates about every week, and that changes things. That being able to be ready to do that kind of testing is really necessary in software culture.
And how should operators really balance vendor collaboration with a culture of this deep troubleshooting and really internal training as well?
Yeah, that lab testing really is going to push operators towards needing to understand how these functions are working and how they think they should be working. So exercising some network architectural decision making is going to be pretty important. Being able to think through how was this protocol intended to be used? Is if we do it the way that you're suggesting, vendor, it may be a good way, but does that open us up to some cybersecurity thing that we need to think through? Or is this moving us, if we take that option, is that going to limit our ability to grow the network in a way that we want to later? So being able to exercise some architectural ownership will probably be new to some of the multi-vendor network operators who are putting together software from multiple places. They've not been in that position to do that before. So they're going to have to be pretty much in the weeds to understand how it works. So that's going to mean both training, get all the training you can from the vendors, and then also training on the standards, how these standards are being used, and then a lot of hands-on experience. It's really important for the engineers, the technicians, the product managers to have the resources to look at how their system is functioning, not just take their word for it from the different vendors, but to look at what it's doing in order to be able to move projects along, be able to move things to deployment. One of the things that's missed sometimes is how just short delays can lead to missing a deadline or a time window.
Yeah.
And then if you're one of these vendors who is offering a solution in the Open RAN space, then you want to be able to accelerate the testing and the proof of concept and the initial deployments. You want to be able to accelerate that. So ensuring that your customer knows how to look at things, that you know how to, that your staff knows how to look at the details of the protocols in the internal operations is going to be critical to actually closing the deal, to actually getting the sale done. And so these things are not just arcane details that are for down the road. They're actually for the upfront implementation and the interop testing. So we've seen a lot of good VoIP software and IMS software, for example, not get selected simply because the vendors were not very efficient at being able to do that deep interop troubleshooting and then exposing that information.
So Mark, what role should network operators play in the quality assurance process when working with smaller and really more agile vendors?
Yeah, it's really interesting because, like I mentioned, the quality is somewhat different because the vendor interop responsibilities are different. So if you're getting everything from one vendor and they're pre-integrating and they're certifying a sort of a package, then in a sense they've done a lot of that QA testing for you. I had an interesting conversation with one of the head of Verizon Labs about 10 years ago. We were talking about what's changed in the VoIP era because he had worked with their VoIP and IMS network when it was basically mostly a single vendor or single source, and then he saw it transition over to VoIP, multiple vendor, and he said, well, software quality has really taken a hit because they expect us to do all the testing, because they can't test on our equipment. So in his case, Verizon had purchased, components from a dozen different vendors and really needed them all to work. Well, they couldn't possibly test all together. He had to do all that testing. And so really what he was getting was software quality that was ready for testing. So when he received it, it was ready for testing, and then he began and he launched, his team launched their own testing. So the QA responsibilities changed substantially when you're going to a multi-vendor Open RAN type of environment. You as the network operator are going to need to test and self-certify a lot of those connections because you can't expect each of the individual operator or the vendors to be able to do that testing for you because they don't have what you have in your lab. Now, every customer, every network operator is unique in a new way. Yeah. And so that means that there's a responsibility for quality assurance that really isn't there under a primarily hardware-based culture.
So why don't Open RAN standards completely eliminate interoperability challenges, and how can operators really navigate these discrepancies?
Yeah, it's interesting. So one of the key things in standards, and I've studied standards from different areas. So, for example, in video standards, I did some research work. I worked with Lucent on network monitoring standards back in the late 90s, early 2000s, and then on the VoIP standards. So one of the interesting things that they have in common is options. They'll have an option, and I referenced this a minute ago when I was talking about DTMF and transfer. That the different vendors will have their favorite way of delivering or handling some sort of data, and so when you have multiple options, it creates more complexity. And so the challenge is, how do I deal with all those options? Well, each vendor is only going to be aware even of a few of the options because it's never, their customers have not asked them to be aware of all 10 potential ways of doing this or all 3 ways of doing this, only 2 of them maybe.
Yeah.
And so they really only have awareness. Well, then when that 3rd way or that 4th way of doing a particular function or that 3rd option, that additional capability that's only used in this particular scenario, when it actually shows up, the software developers haven't actually built that in. They haven't built in the capability to prepare for it. So options in the standards are actually one of the kind of the bane of the implementer and the system integrator's existence.
Yeah.
Because we have to figure out which options were selected by this one and which options were selected by this one. And it was interesting because it took a good 10 to 15 years in the multi-vendor IMS space for these options to start to get really crystallized and to figure out which options were really required. So now, if you're an IMS vendor and you're working with a new cell handset or software, or you're working with a new type of hardware device, it's become a lot clearer. What are the important options? But if you rewind 15 years ago, it just wasn't as clear. I think that's the point we're at with Open RAN right now, is it's not quite clear which of the capabilities that are in the standards are really optional, truly optional, or which of them are the ones that are technically optional according to the standard, but everyone's going to do them because everyone's going to require them. So knowing about those options, there's a challenge in these software-based protocols of kind of perfectibility. They want to keep the option open to make the standard a little bit better, or to add some new enhancement, or for a new vendor to come along with a new idea. And that sounds good, but from an implementer's perspective, it's really challenging. So that options, that's actually one of the things that makes the implementation of a multi-vendor standard like the Open RAN standards a little bit harder than it probably is expected to be in some cases.
So, Mark, what mindset shifts are required for really operators transitioning from these traditional hardware-based RAN to a more software-driven, DevOps-oriented model?
Yeah, that's a great question. The hardware culture and the software culture could hardly be more different. The hardware culture is about shipping perfection. We've designed something, we've tested it, we've checked its RF emission, we understand it really, really well, and so the hardware culture is really good at making high precision electronic RF components. They can do that really well.
Yeah.
The software culture is about shift early, let's test it. When we ship early, we'll test it, and then we'll figure out what's really working.
Sure.
We're going to do patching and updates. So patch early, patch often. So get it out there in the field. Let's start to get some data on this. So we call it data-driven development. Everyone loves data-driven, except data means that you just learned a lot of things that didn't work. And so it's actually something that you got to prepare for. You got to prepare for that expectation. It kind of connects back to the QA conversation. You got to prepare for whether you're going to be ready to accept something that is partially broken, you're ready to go do testing, and then report back all the bugs and issues that are discovered and that need to be remediated. That's on the software culture. You're constantly doing remediation. So remediation is part of what you're doing. On hardware, you're kind of expecting it to be largely in pretty good shape because it's got to be tested, but it's going to take a lot longer to develop and then innovate to the next generation. Whereas software, you're getting new generations of software in effect every few weeks in a lot of cases. So that mindset between going to we're patching early, we're patching often is something that's got to be understood. So, for example, if you're planning cell site deployments and every new software update is going to require several hours of downtime, then that's actually going to be a pretty big hit. If those software updates start coming from your vendor every few minutes or every few hours, it's going to feel like every few minutes. But when it comes on a regular basis, you can't afford to do those software updates nearly as readily. The cell site vendors, the network operators need to be prepared for doing early and frequent patching and updates, and then being able to certify and test things in their labs on basically a continuous integration basis. They need to be able to bring these things in, test them, and then get them deployed readily. And that's a big difference from the idea of, well, we're going to do a big upgrade, and this upgrade is going to happen every quarter, and it's going to be our schedule. The network operators are not always going to be able to decide the schedule that they take the updates.
Yeah. So, Mark, how can Open RAN operators really enhance cybersecurity strategies to mitigate these risks associated with multi-vendor interoperability?
Yeah, cybersecurity is something that I think the Open RAN operators are going to need to take seriously in a new way. Like I've mentioned, the talk of zero trust networking is a good idea. It's the right way to do it. I'm glad to see that those things are being baked into the standard, but I don't think it's exactly the way that things are being tested right now. So the zero trust networking concept is effectively assuming that you've got malware everywhere, so that every device, whether it's your network operator PC or it's a device that you're bringing onto the site, and that you're plugging into the local, the Ethernet, the front haul Ethernet switch, that those devices all have malware on them. And so you're bringing malware into the network at all times, and that's actually matching reality. So, for example, smartphones are one of the primary ways of delivering malware into enterprise networks now, because they're allowed to attach to the internal Wi-Fi networks. And so if you think about that malware kind of everywhere problem, then you don't really have an isolated section of the network. So what zero trust networking would mean was that if a testing device is plugged into your front haul Ethernet switch, that device may have malware too. And I don't think that's the way that folks are directly testing it as much as they should be. So that concept that every network should be ready to defend itself, every component should be ready to defend itself, really needs to take hold in the Open RAN community. It's a software quality issue, partially. So the sooner, I would say, as a general piece of advice, the sooner the software developers can actually get their software onto the internet, and I mean the public internet with all the malware and all the attacks, on the internet and test it there, they're going to start to discover and going to be able to mature their software in a way that's really impossible to do in an isolated lab with a private Ethernet switch and private IP addresses. It's really going to change things. So the zero trust is the right way to think about it, but they really need to go, the team really needs to go all the way into implementing and testing with as much exposure as possible. And that don't mean that we're putting your real cell sites, your production cell sites, on the public internet. What I mean is that you're putting the software in a situation where it can be exposed, and you can figure out what's happening to it, how are attackers attempting to attack it. Without that kind of testing, you're not going to get the software maturity that you need to truly defend yourself. So we saw it a lot in the VoIP world. If we look at the SCADA in the industrial world, we're seeing a lot of work come out from the federal government, CISA, looking at industrial vulnerabilities that are discovered pretty much every week. And it's largely because these are Internet Protocol-based devices that have not been fully matured yet, because they were not designed assuming that malware is everywhere, that attackers are launching attacks from everywhere. So I have customers in the telecom world where malware and attacks have been launched inside their trusted networks, and that really needs to be the mindset of the Open RAN developers and operators.
Mark Lindsey with ECG, it's good to talk to you, and it'd be good to see the developments this time next year as well.
Yeah, thanks very much, Abe.
Thanks, Mark.